Have you ever wondered how cement is made? It's a crucial material in our daily lives, yet its production remains a mystery to many. Imagine a world without cement. It's difficult, isn't it? This ubiquitous material is the bedrock of our modern built environment, forming the core of our buildings, roads, bridges, and more. From the tallest skyscrapers to the smallest garden paths, the strength and versatility of cement make it an irreplaceable part of our lives. In essence, cement is a finely ground, non-metallic inorganic powder that, when mixed with water, forms a paste that sets and hardens. Sounds simple, right? Yet the process of making it is anything but. It's a fascinating journey that begins with the extraction of raw materials from the earth and ends with a product that is as common as it is essential. The production process of cement is a complex one, involving numerous stages. It starts with the mining of raw materials, including limestone and clay, which are then heated in a kiln to high temperatures to produce clinker. The clinker is then ground into a fine powder and mixed with gypsum to create the final product, cement. In this video, we'll explore each step of this process in detail. We'll begin by looking at how the raw materials needed for cement production are extracted and prepared. Then, we'll move on to the heart of the production process, the kiln, where the raw materials are heated to create clinker. After that, we'll dive into the grinding process and the addition of gypsum. Finally, we'll discuss the quality checks that ensure the cement you use is up to standard and how it's distributed to reach your local store or construction site. Cement is a material that's as fascinating as it is fundamental. Its production process is a marriage of nature and technology, a symphony of chemical reactions and mechanical processes. It's a story of transformation, from raw, earthy materials to a smooth, gray powder that holds our world together. Now that you have a general idea, it's time to delve deeper into this fascinating process. The journey of cement begins with raw materials in the form of limestone and clay. You might be wondering why these specific materials. Well, limestone is rich in calcium carbonate, a substance that's crucial in the formation of cement. Clay, on the other hand, is a great source of silicates and alumina, which are also essential in the cement-making process. To extract these materials, we venture into open-pit mines, where we strategically remove layers of soil and rock to reach the valuable limestone and clay beneath. This process is carefully planned to minimize environmental impact and ensure the long-term sustainability of the mine. Once the raw materials are extracted, they are transported to a crushing plant. Here, powerful machines crush the limestone and clay into a fine powder. This process may seem violent, but it's necessary to break down these sturdy materials into a form that can be manipulated and transformed. Now you might be thinking, why do we need to crush these materials into a fine powder? Well, the answer lies in the chemistry of cement production. The smaller the particles, the easier it is for them to react with each other during the heating process. This reaction is what ultimately leads to the formation of cement. So, after the raw materials are crushed, they're mixed together in the right proportions. This mixture, often referred to as raw meal, is then ready for the next stage. But just before we move on, let's take a moment to appreciate the work that's gone into preparing these raw materials. From the careful extraction of limestone and clay to the meticulous crushing and mixing process, every step is crucial in ensuring the quality of the final product. With the raw materials prepared, we're ready to move on to the next step in the process. At the heart of cement production is the kiln, a large cylindrical vessel that can reach temperatures over 1,400 degrees Celsius. This blazing inferno is the stage where raw materials are transformed into a substance known as clinker. Let's delve into the details. The main players entering the kiln are limestone and clay, but they're about to undergo a serious makeover. As they journey through the kiln, they are subjected to intense heat, gradually escalating to that peak temperature of more than 1,400 degrees Celsius. It's an environment as hot as the outer crust of the sun, and it's this scorching heat that triggers a series of complex chemical reactions. The limestone and clay fuse together, their atoms rearranging themselves to form new compounds. The result? Clinker. These are small dark gray nodules about the size of marbles, and they're the main ingredient in cement. Temperature control is a critical part of this process. Not hot enough, and the reactions won't occur. Too hot, and the materials can overcook, leading to a lower quality product. It's a fine balance that requires constant monitoring and adjustment. But the kiln's work doesn't end with the creation of clinker. Next comes the cooling process. After the clinker has been formed, it exits the kiln and enters a cooler, which rapidly brings down the temperature. This sudden cooling is crucial. It stabilizes the clinker, locking in the new compounds and giving it its strength. Just like baking a loaf of bread, the kiln's role in cement production is both an art and a science. It's about understanding the materials, controlling the heat, and timing the process just right. Once the clinker cools, we're one step closer to the final product. But there's still more to this fascinating process, so stick around as we grind our way to the finish line in the next stage of cement production. With the clinker ready, it's time for the grinding process. This stage is all about reducing the clinker into a fine powder, something that might remind you of the consistency of flour. It's a transformation that's not just for aesthetics. It's crucial for the functionality of the cement. Imagine, if you will, the clinker as a collection of rocky boulders. These boulders are made up of elements like calcium, silicon, and aluminum. But in their current form, they're just too big and too tough to be useful. That's where grinding comes into play. The grinding process breaks down the clinker. It's like a giant pestle and mortar, grinding and crushing the clinker until it becomes a fine powder. This powder, often called cement, has a consistency that allows it to mix with water and other materials, creating a paste that hardens and holds its shape. It's the stuff that binds bricks and gives strength to our buildings and structures. But we're not quite done yet. There's one more ingredient we need to add to the mix: gypsum. Gypsum, a soft white mineral, is added to the ground clinker during the final grinding process. You might be wondering, why add gypsum? Well, think of gypsum as the control knob on the cement. Cement, by nature, reacts with water and starts to harden. But if it hardens too quickly, it becomes difficult to work with. That's where gypsum comes in. It slows down the reaction between water and cement, giving us more time to shape and mold the cement before it sets. This is a crucial step because it allows builders to use the cement in a wide variety of constructions. So the clinker is ground, the gypsum is added, and we have our final product. A fine powder that, when mixed with water, forms a paste that hardens over time. And just like that, we have cement. But the process doesn't end here. Every batch of cement undergoes rigorous quality checks before it reaches the market. It's not enough to just produce cement. The real challenge lies in ensuring the consistency and quality of every single batch. Before our cement hits the market, it must meet a series of strict quality standards. This is where our quality checks come into play. First off is the fineness test. This is a measure of the size of the cement particles. The finer the cement, the greater its surface area for chemical reaction, which ultimately leads to stronger concrete. Next, we test for soundness. This ensures that the cement won't expand or contract once it sets. Any significant change in volume could lead to cracks in the concrete, which is something we definitely want to avoid. Then there's the setting time test. This checks how long it takes for the cement to start setting and reach its final set. It's crucial to hit the sweet spot here. If cement sets too quickly, workers won't have enough time to use it. If it sets too slowly, the construction timeline could be delayed. Lastly, we perform a strength test. This measures the compressive and tensile strength of the cement. In simpler terms, we're testing how much load the cement can handle without breaking. Once the cement passes all these checks, we're ready to distribute it. The cement is packed into bags, or in some cases, bulk containers, and then loaded onto trucks, trains, or even ships. These modes of transport carry our cement to various parts of the country, and sometimes even overseas. At the destination, whether it's a bustling city or a remote village, the cement is unloaded and finally makes its way to the construction sites. Here, it's mixed with other materials like sand and water to create concrete, and then used to build everything from homes and schools to bridges and skyscrapers. Next time you see a building under construction, you'll know a little more about one of the key materials that makes it possible.